For more information on tutoring, personalized video solutions, or how to support Moof University and the production of more videos, check out moofuniversity.com. Thank you and enjoy. So in this video, I just want to talk about ionic versus covalent compounds and a quick overview and summary. So first up is method of formation. How is it that ionic compounds form? Well, they form via the transfer of electrons, right? One atom either gives up its electrons entirely to another, or you can think about it as one atom steals electrons from the other, right? But the point is that there's a complete transfer of electrons from one to another, okay? Whereas covalent compounds, that doesn't quite happen. Instead, they share electrons, okay? So there's a sharing of electrons. Sharing is caring with covalent compounds, okay? Now, when we think about a unit of an ionic compound, the ionic compounds unit, we think about it being a formula unit, which tells us the ratio of cations to anions in a crystalline array of a sample of that ionic compound that we're talking about. Whereas covalent compounds, they have individual units called molecules, right? The distinction between them is important. I mentioned it a little bit more in detail in the previous video. Okay. Now, the state of matter at room temperature, I didn't really talk about this in the intro or in either of the two videos before, because it's really just a quick fact that you should know, at least in my opinion. There are tons of details about it, but when it comes to ionic compounds, they are typically solids at room temperature, right? You think about things like examples like sodium chloride, right? Table salt is a classic example. At room temperature, it's solid. And if you've ever tried to melt salt, you've probably failed. Now with covalent compounds, they are typically liquids or gases at room temperature. Okay, you think about a classic example is water, right? Water is a liquid at room temperature. Another example would be something like H2 gas or O2 gas. We breathe in oxygen gas. That's a gas, right, at room temperature. So if we think about the state of matter at room temperature, we can also sort of basically determine whether their melting points or boiling points would be high or low. Now, I just mentioned that if you've ever tried to melt salt, you've probably failed. So with ionic compounds, their melting points and boiling points are often tremendously high. Okay, whereas covalent compounds, melting points and boiling points are relatively low. Right? It's fairly easy to boil water. Right? If you've ever cooked pasta, you just put it on the stove, and soon enough, it'll boil. Right? Also, with water, it melts at 0 degrees Celsius, right? 32 degrees Fahrenheit. So covalent compounds have relatively low melting points and boiling points. Some examples of each, I've already mentioned a few. Ionic compounds, NaCl is a classic example. MgCl2 is a classic example. There are, of course, many more types of ionic compounds. Covalent compounds, what did I put here? CO2 and water, carbon dioxide gas, and H2O is water. Right? Well, I hope that video was helpful. Thanks for watching. If you found that video helpful, don't forget to like, comment, subscribe, and share with friends. Thank you and happy studying.